I would like to thank the team of PROTO and the technical team behind it for organizing this wonderful webinar at this occasion. So I like to thank everyone. I like to thank the participants for joining at this moment. So thank you so much, and welcome you all to this wonderful session. And this session is all about the absolute fundamentals of machine learning, and we're going to predict the positive cases in COVID-19. Okay, the positive cases reported for COVID-19, and we're going to predict that for a particular state in India. So not for the whole India, not for the world. And we're going to predict for a particular state in India called as Tamil Nadu. And I'm presently here from Tamil Nadu, right? So yeah, let me introduce myself. And I am Sujithkumar, MA. So that's my initial actually. Okay, so Sujithkumar, and I'm a student of PhD College of Technology. I'm a student. Okay, and again I'm a course instructor in Udemy portal. That's a US-based portal. Okay, going to see in great detail about the equations, and of course we'll see only the concepts. Okay, 90% will not have any equations, but 10%, of course, we should have some equations. So this is our agenda. So first of all, we'll be having a very simple description that's actually non-technical. I just want to insist that, okay, because there may be technical geeks out there. So this is actually non-technical description on machine learning. Moving on, I'll be telling you about the power of data and the data which we are actually going to use in this webinar, okay. And after that, we'll be seeing about linear regression, and I'll be telling you what is linear regression and how does the algorithm work, okay. And of course, we are not going to write our own algorithm, okay. We are not going to implement the algorithm by our own, okay. There are some inbuilt libraries in Python which will do for you, fine. And we have a train test split, and I'll be telling you what is train test split. That's a very basic concept in machine learning. If you are a beginner, then you can actually understand that very easily, fine. And after that, I'll be telling you the standard Python libraries like NumPy, Pandas, scikit-learn, TensorFlow, and we got two interesting libraries in machine learning, right? Scikit-learn and TensorFlow, and I'll be telling you about that for machine learning. And we are going to use only scikit-learn. You might be data pre-processing. Machine learning is all about data science, right? So for data pre-processing and data visualization, we'll be using NumPy, Pandas, and mathematics plotting library. In other words, it's called as matplotlib. Okay, this is the expansion is actually mathematics plotting library. Okay, we're going to use that. I'm going to visualize my COVID-19 data. Okay, and I'll be showing you how it looks like. Okay? And that's a very interesting point of this webinar. I'll be telling you that later. Fine. And we have an interactive environment for Python. Okay, to write our Python code, because you may be using your PyCharm, Visual Studio Code, or the default Python ideally to write your Python code, right? But here we are going to use a very favorite toolkit for data science. Okay, very favorite environment for the data scientists. They are called as Jupyter IPython notebook. Okay, we are going to use that. Okay, and I'll be telling you what is IPython notebook and why it is so so favorable when compared to the other idealists. Fine. Moving on, I'll be telling you about the data sets which are available in Tamil Nadu government website, and we are going to download that. That's actually open sourced, and you can use that for your analysis. That's why I'm using that, okay? And I don't own any copyrights for that also, fine. And moving on, we'll be creating our own, not our own, actually it's a machine learning linear regression model using a library. And hold on, if you don't understand this, we'll be seeing in great detail, okay? So yeah, finally we'll be predicting the number of positive cases for a particular number of dash. I'll be filling this dash afterwards, okay? For a particular number of test cases, okay? So we'll be finding the number of positive cases, and that is the conclusion of the webinar. This is our agenda. The whole webinar will be, like this, okay? Okay, let's start our content actually. First of all, I'll be explaining what is machine learning, okay? So what do you mean by the word machine learning, okay? And why it is producing an output? Because every learning must have an outcome, okay? And that is actually the complete learning, okay? So every learning must have an outcome. According to me, every learning must have an outcome. Say for an example, you are learning JavaScript, okay? JavaScript is again rising programming language. If you are learning that, and you should be in a position to develop a should be in position to work as a backend engineer for a website, right? So if you are learning JavaScript, the outcome must be developing, working in as a backend engineer in a website. Okay, so that's every learning must have an outcome. Okay, so here itself, the machine learns from something, and as an outcome it produces an output. Okay, so learns from something and produces an output. That's pretty simple, right? That's a non-technical description I want to give. Okay, again, a very silly question. From where do we learn? We learn actually from the resources like books, internet, articles, and lectures, right? So we learn from those stuffs, okay, those information. Again, a lot of information we can say. Here, our machine learning model, when I say machine learning model, think of like our machine, okay? So machine learning model, it learns from the data, okay? So we are also learning from the data, right? Because inside books, what we'll be having is only data, right? So we are also learning from data, but our machine learning model is going to learn from the data, and that data is called a data set, okay? So that's called as a data set, okay? So I'll be introducing what is a data set in shortly, and when I say data set, just break the word and understand the meaning. It's nothing but a set of data, or in other words, it's a collection of data. Okay, so we've got a lot of data there, and our machine learning model is actually going to learn that data, and as an output, it produces something. Okay, again, I'm repeating. Our machine learning model is going to learn from the data, okay, data set, and as an outcome, it produces an output, and that output can be anything as per your wish. Not anything, you have to structure the output, and some of the possibilities are given here. Okay, some of the possibilities of some of the applications of machine learning. Okay, so first one would be predicting the sales price of a product. Yeah, mostly people use that, right? They predict the sale price of a product using this concept called as machine learning data science. Fine. Moving on, we can predict the stock value, and I don't know what is stock value actually. Okay, so to be honest, because I'm not much into that, because I'm from the science background, not much into commerce. Okay, and third one would be predicting the disease or disorder, and that's the very crucial application, right? Because if you do something wrong in sales price or stock value, machine actually predicts something wrong, in sales price or stock value, it is not actually going to affect much compared to this one, third application. Okay, compared to the third one, these two will not affect much, because when I predict the disease or disorder wrongly, and that is going to be a disaster again. Okay, so that's a crucial application where you have to think about a lot to avoid some errors. Okay, you have to be more accurate. The machine learning model should be more accurate in that particular application. Fine. So moving on, we'll be using for classification again that's pretty simple, and that's pretty famous in Python. Okay, and identifying an object. Okay, the object recognition we'll call that, and for that we'll be using some libraries called as OpenCV in Python to recognize an object. Okay, to recognize face also. For facial recognition also, we'll use a library called as inbuilt library called as OpenCV. Okay, this OpenCV stands for computer vision. Okay, that's a computer vision library, and our webinar is actually doesn't have the scope of that. Okay, this actually that particular topic is beyond the scope of this webinar. Fine. So actually you can start learning machine learning from this particular webinar, and you can actually explore more later in future. Fine. And optical character recognition, that's basically that will recognize your handwriting. Okay, so if you write something in notebook, your text, that will recognize that, and that will be converted as a printed text in the computer. Okay, that's called optical character recognition, so OCR, and that will be done by again an inbuilt library available in the data set. You would have identified that this data set contains information of different types of houses. Okay, and in other words, this is going to talk about houses. Okay, house and house prices. Fine. Different types of houses, or different houses and their prices. Okay, and this will be used for predicting the price of house in future. Again, I just want to emphasize that this is actually used for predicting the price of a house. Okay, so this is the data set available, and this is actually downloaded from, I just want to annotate here, actually downloaded from this website. Okay, so again, I don't own any copyrights. Fine, so download from this website, and let's analyze the column one by one so that we'll understand what is a data set and what are the important terminologies available in when you talk about data set. Fine. So first of all, we'll be having the house ID. Okay, this is called as house name, and that is not going to affect your original data, right? It's just your ID, okay, just your house name, and this will not actually affect the price, okay? This will not actually affect the price. And my intention would be predicting the price, right? So my intention would be predicting the price. So my sales price would be my output. Fine, I'll just set it as OP, okay? So my sales price would be my output, okay? And after determining what I'm going to find, okay, I just want to determine what I'm going to find, and I've predicted that sales price would be my output. So I just make it as my output in my data set, and that is going to be called as target, okay? So output is called as target actually. So your sales price is your output or target. After fixing your target or after fixing your output, after determining what you are going to find, you have to find on which factors the target depends upon, okay? So that's the last point here. Target depends upon what, okay, on which factors. Here in this data set, my sales price is going to depend upon the size of, obviously, because if the size of my house increases, if I have a larger house, then I'll be having I'll be having a higher cost, right? A larger house would cost much bigger, right? So if this increases, if size increases, then sales price is also going to increase, and there is a direct relation between these two, and you have to identify that, and you have to choose this as your input. Fine. And this column is called as a feature, okay? So that's a very important terminology, very basic terminology. So this is called as a feature, okay? So your input is called as a feature. Every column is actually a feature when you talk about data set, okay? So this is a feature, so that's your input. Fine. And you also have age here, and that also can be taken as your input. Fine, because my price is also going to depend upon, I'm sorry guys, I'm just doing some messed up things here, I'm sorry. So my price is also going to depend upon this age, right? So because if my age, nothing but when I say age, that's the difference between the present year and the year in which the house is actually constructed, okay? How old my house is, okay? How old my house is, okay? So yeah, this house, say Avalon, is 13 years old, which means something older. So I won't prefer that, okay? So I'll be preferring this new house, just 1 year old. So it will be looking somewhat new. What you are going to find then is this distance. I mean, the distance from the data point to the line, to your imaginary line, to your linear line. I think this is called the machine learning. This may be directly related to the machine learning model. Okay, so this distance is called as error. Okay, this is actually an error, right? Because your data point is actually not fitting to the line. So that's why you are actually trying to fit that, and this distance is actually an error. Okay, so this is an error. Loss function to be very, very minimum. Okay, so if you want the loss function, I mean the sum of all the distances should be very, very minimum, so that our data points would actually fit to the line. Okay, if it actually fits to the line, my prediction would be more accurate, and I'll talk about that later. Fine, my prediction will be more accurate. So moving on, and this I would like to insist, because what is the equation of the straight line? Let's move back. M will be called as, I think, in some other names in boilerplate machine learning stuff. So I'm just going to neglect that. Let me call it as M. That will be very simple. I just want to make everything simple. Okay, so M and C, and M will be your slope and C will be your intercept, right? So depending upon these values, if I change M and C, you will be actually having a different lines here. Okay, a family of straight lines. If you change the value of M and C, you'll be having a family of straight lines here. And wait a minute. So yeah, so you have to vary the value of M and C, and you have to draw a lot of straight lines. Okay, this actually this line may have a separate unique M and C. This line may have unique M and C, and like this. You have a family of got a family of straight lines here, and the point here is you have to choose a line in which the cost function is actually minimum. I told you that the cost function is nothing but the distance between, distance between the data point and the line, right? So sum of all the distances of the data points from the line. That's the cost function. That's the error function. And if it is minimized, then this data point would actually going to fit our line, right? Almost going to fit our line if the cost function is made minimum. If the distances is made minimum, then these data points is actually going to fit our line, and that is the objective here. Okay, so I'm going to choose a line where the cost function in minimum. In other words, where my data points is actually going to fit the line. Okay, so that's called as the line of best fit. Okay, I just want to emphasize that. Okay, we choose the line of best fit. Okay, and line where the cost function is actually very minimum. Okay, because you don't want errors, right? So if you choose that, and your prediction would be more accurate. Okay, not 100%, but would be accurate to some extent, and we'll be checking our accuracy in our discussion in the practical session. So we are looking at the theory session here. In next slide, this theory session will end, and we'll go to practical session. Okay, so and let's assume that violet is our line of best fit. Okay, because in violet line we got the cost function to be very minimum. Okay, so when I say cost function, the distance between the line and the data points, right? So violet has a very minimum cost function. Let's assume that. Okay, and making that assumption, that means the violet is my line of best fit. Moving that, and I've chosen the line of best fit, and I've made an assumption that there my cost function is actually minimum. Cost function nothing but, again, I just want to tell it again, distance between the data point and the line. Okay, and the sum of all the distances, that's the cost function actually. That's minimum. So yeah, that now we have found the line. Okay, you have found the line of best fit, and it means that you have actually trained the model. Okay, you have actually trained the model for your data values. For your data values, data points, you have actually trained the model, which means you have made the line of best fit. Okay, line where the cost function is minimum. You have made the line of best fit. After making the line of best fit, for prediction, okay, for future prediction, let's say I want to predict the number of positive cases for this value of x. Okay, for this value of number of test cases, I just want to predict the number of positive cases. What I will do, since this line actually fits our data to some extent, we have minimized the cost function, so this line actually fits our data to some extent. Of course, we got some distance here. Let's neglect that. Just for an example, okay, just neglect this. This line actually fits our data to some extent. Okay, we have parameterized the value of m and c. Okay, in y equals to m and c, we have parameterized the value of m and c. We have actually optimized the value of m and c in such a way that this line actually fits our data points. In other words, to be more technical, in this line, the cost function is actually very minimum. Okay, so once you have found this line, for a sixth value, we got 5 different data points here. So for a sixth value, if you want to do prediction, we just extend this and find a point in your line of best fit, and that is going to be your number of positive cases for this test taken. Okay, so that's going to be your prediction value, and that's how it predicts the value. It's just going to try to fit a line to our data points, and if it is linear, the accuracy will be very high. Okay, and after fitting the line, it's just for prediction. It's just going to extrapolate the line, and it's going to find the prediction value, and that's going to be a prediction value. You can extrapolate the line and find the number of positive cases for any number of tests taken. Okay, that's actually possible. That's how linear regression algorithm works. Let's have a quick recap. In 1 minute, I could have a recap. It's a very simple concept. So again, you have a lot of mathematics behind it. I'm neglecting everything because I just want it to be theory as well as practical. If I explain that, it will be somewhat only theory. Okay, so you got some data points, your own data points, your values. After that, we just try to fit a line. Okay, and you fit your data points to the line and find the distance between the data points and the line, and sum of all the distances is called as cost function. You have to find that, and you have to change the value of m and c, and you have to get different lines, and you have to choose a line in such a way that the cost function is actually minimum. In other words, you got the line of best fit. Okay, that line actually perfectly fits to your data. Not perfectly, somewhat accurately fits to your data. Okay, it will not perfectly fit, and if it is linear, it will definitely fit. Okay, So for prediction, just want to extrapolate the line and find the number of tests and find the number of positive cases for number of tests. And that's all about the theory. Now it's time for us to move on to the our interactive environment. So let me just I think I don't want to make the applications and sorry guys, I just have one more topic here. Okay, our train test split. I'll just explain this also. Fine, and this is a very simple concept. You have an original data set here. Okay, you got a data set here, and this data set talks about the I think the characteristics of a flower. I don't know about flowers. Okay, so you know Setosa, that is a species. Okay, let's leave that. Okay, so you got a information of flowers here. So each row is an example for a flower. Okay, so when I say I have 5.1 sepal length, 3.5 sepal width, I don't know the units, I don't know the dimensions. 1.4 petal length and 0.2 petal width. And okay, this talks about a flower. Okay, so flower data set. Okay, the point here is I just want you to understand train test split. So what is going to be train test split? So in our machine learning discussions in creating our model, that's called a model. Okay, so for our model, we are not going to give the whole data set. Okay, we are not going to give the whole data set as the original data set as the input to the machine learning model, right? We'll be just having only we'll be just having a little bit for our testing. Okay, that's called train test split. Fine. In other words, we have 1, 2, 3, 4, I think 10. Okay, let's assume 10. Okay, so we have 10 different rows here. Mostly 6 will be like 7 will be taken for training the model. 7 will be given as input and 7 will be given as input to the model to learn. Okay, to learn from the let me say my output here is species and my input here is these features are my input and my output is whether it is Setosa or not. That's my output. Okay, so I'll just give only the 7 rows for my model to learn, and that's called as train data. I'm just going to train my model only with 6 rows here. I hope 6 rows. Okay, 5 up to 5.4. Okay, I'm just going to separate this data. In other words, I'm just going to split this data set, and I'm just going to give only up to 5.4 as my input to the train data, input to the machine learning model. That's called as train data. Once it is learned, in other words, once it is learned completely, okay, learned completely from our train data, now our machine learning model is actually ready to predict values, right? And to test that, I'll be using some data examples from this data set called as test data. That's why I'm splitting train data and test data. Some rows will be actually used to train the model, and the remaining rows will be actually used to test the model. After it is trained, we'll be trying to test the model. Okay, we'll be trying to find the accuracy. For that, we'll be using the test data, and we'll be going for mostly 80-20 split, which means if you got 10 rows, 80% will be taken for training the data, and only 20% will be taken for testing the data. Okay, and I hope you understood this concept. That's why we mean that's what we mean by train test split. Okay, and this is actually for the beginners of machine learning. I hope it's going good. Okay, so let me now go to the practical session. Before that, I'll just come to the Google Meet. Okay, session is going good. I just want your replies so that we can move on to practical session in another and complete it in another 30 minutes. I hope you have understood. Thank you, doctor. Thank you guys. Okay, let's minimize and actually move on to the practical session. So just press new tab, and I told you that first of all, let me download the data set. Let me teach you how to download the data set from the internet, and you can search data sets for machine learning, and you'll be getting a lot of examples if you are a beginner. Okay, it will be useful for you. In time being, I'm going to download a data set from TN government website, the COVID-19 data set, which is actually available there, because our intention is to predict COVID-19 positive cases. Okay, so I'm just saying TN COVID. Wait a minute, TN. I hope my screen is visible. Right? Yeah, thank you, team. Thank you. TN go with data set. If you press enter, I'll be getting the data set here. Just go to downloadable data sets in available in TN government, and you can download the data set of any other state also if it is available. I don't know whether it is available or not, but you can download. I think Kerala has and Andhra Pradesh has their data set. Okay, so in this, this is the official website of TN government. So in this, go to daily case information. Okay, you have to download that. Just click this daily case information, and it will download it in just 1 second. Okay, that's because and understand that this is in the format of an Excel sheet. Okay, so please note that it's in format of Excel sheet. I just want you to note that because we are just going to convert it as in another format because Excel will not help us. Okay, so just open this. Just look how it just looks like. Okay, I'll just close the PowerPoint. Okay, so I'll make some free space. I got only 4 GB RAM. Okay, fine. Super. Fine. So you got the download data set here. This is the data set which is available in TN government website, and you got a lot of columns here. You got at least 19 columns, I hope. Yeah, the count is 19 because I already downloaded this, so that's why I'm saying. Okay, so 19 columns. And you got a lot of empty rows also, and we are going to clean that rows in a while. Okay, we'll be cleaning that, not in Excel but in our Python code. Okay, fine. So you got a lot of empty rows, and yeah, this is our data set. And this is in Excel format. I don't want this to be in Excel format. I just convert it in another format called as comma separated format called as CSV. Okay, that's called as CSV, almost like an Excel sheet. And I could explain this, but that will take more time. I think we are nearing the end, so let me when I say CSV, think like that. CSV is almost same as Excel sheet. Okay, and it will be each value is comma separated. That's why it is called as comma separated file. Okay, let me go to file, save as. I'll just store it in a particular directory, and watch this why I'm doing. Okay, I'll be explaining you this later. Okay, let me go to browse. Okay, don't store it randomly somewhere. Wait a minute. Don't store it randomly. Go to your C disk. I'm already in the directory. Okay, go to your C drive. Go to users. Go to your username. In this name, my username is mask. Go to yours, and you have to save this here. I'm just going to tell you why. Okay, and I'll be saying it as public TN dataset. Okay, I can give any name. .csv. Okay, .csv, and I'll make it as comma delimited. Fine, CSV. Save this. Yes. Okay, save this. After that, so you have successfully downloaded the data set, and now it's time for me to introduce you to the my favorite environment called as Jupyter IPython notebook. It's actually okay if you have a prior experience in working with Python. You might be if you are a very beginner, you might be working with the default ideally which comes with Python if you are a Windows user, of course. And in other words, you may be going for PyCharm. That's also very good ideally provided by JetBrains. And you may be also working in Visual Studio Code. I'm going to download another interactive environment like that called as Jupyter IPython notebook. For that, I'll be installing a distribution called as Anaconda. So I'll just type Anaconda distribution for Windows. I'm using Windows here. You can download it if you are using Mac also, Linux also. So go to individual edition. I'll be telling you what is Anaconda in a while. Okay, that's actually a distribution available to download all the modules or libraries which you are going to use. In Python, we got a lot of libraries, and if you want, you can install it one by one. You can install it one by one also using your pip. I hope you know what is pip. Okay, so you can install the libraries using pip. But here, I just want it to be installed everything in one download. Okay, that's why I'm installing Anaconda distribution. This will be coming with 19 packages. I hope 19 data science packages. Okay, data science toolkit. And if you install this in your computer, this will be having 19 different Python machine learning packages. Okay, or R programming. Okay, so that's beyond the scope of this webinar. We'll leave R programming. Fine. So yeah, that's open source library, and yeah, you have got a lot of different libraries available. So we are going to use Jupyter IPython notebook. Yeah, we're going to use that. And we are having scikit-learn, okay, and that's a pretty interesting library, guys, trust me, okay. So we are going to take our machine learning model from scikit-learn library. We'll be using NumPy and pandas for pre-processing our data or for reading our data. Pandas will help you to read your CSV sheet which you have downloaded, right? And matplotlib, that's actually by the name you would understand that's just to plot your data, okay. So that's it. You got a lot of different libraries. We are not going to use SciPy, TensorFlow and all. Fine. So just download it here. Okay, you can go below and just download it from 64-bit graphical installer. Okay, so just download it. I've already downloaded it for you, and it's a huge package. If you're downloading it for the first time, it will take at least 45 minutes, I hope. Okay, you have to wait patiently. Okay, so yeah, let me minimize this. I've already downloaded that. So let me go to my search. I'm just typing Jupyter IPython. So you got Jupyter Notebook, and that will be installed in by default with Anaconda. Okay, so just click this to open, and the moment you click the Jupyter IPython Notebook, it will create a local host for you. Okay, I'll be telling. I think, and that's a pretty different concept. It will be creating a local host for you. We couldn't explain everything because it will actually consume much time. Okay. Yeah. So it will create a notebook for you, a notebook environment for you in your default. In this case, it is Microsoft Edge is my default browser. This will create a local host for you. So yeah, this is your default directory. That's why I have stored my data set. You can see we got the data set here, public key and data set in a particular directory. I told you to watch that, right? So I have stored that data set in a particular directory in my C drive, right? So again, if you open the Jupyter, and that data set will come here because Jupyter has a default library, a default directory set for you in your computer, and that will be mostly in your C drive. Okay, super. So yeah, let me create a new notebook for you. Notebook is nothing but an interactive environment again to work with Python. Okay, just press note. Just go to new and click that. Click Python 3. Fine. So this will create a notebook for you, and let me retitle it. First of all, click untitled and rename it. Let me rename it as PROTO webinar COVID. Okay, some random names. Okay, rename it. And okay, so this is my interactive environment. And if you are a beginner, I'll be explaining this in okay, so you have cells here. Just go to click plus here. So you just click add button, the plus button. You'll be getting a lot of cells, okay, and that will help you to write your Python code. Okay, you can write Python code in this cell. Okay, you can actually write your Python code. And if you're a beginner Jupyter, and I'll be highly suggesting you to start using this. Move on from pseudocode channel. This is actually cool, and this actually works based on the concept that Python is interpreted, not compiled. Okay, because each line is interpreted. That's why you got different cells here. Where you can actually separate your code. Okay, you can write a function here, and you can call the function here. Like that, you can separate your code. It will be more readable, right? Okay, I hope I'm making sense. Fine. So let me just work with this library. Let me say print hello world. Hello participants. Hello. Fine. So I'll just put enter. If I press enter, the moment I press enter, it will direct me only to the next line, and it will not execute this line. Okay, it will just direct me to the next line. Fine. And I can write one more print statement here. I'll be saying hello world. Okay. And the moment I press enter, it will just direct me to the next line, and only if you click run or only if you click shift and enter, this will execute the cell for you. So this is actually executed, and once it is executed, you get a number here, and that says the number in which the index in which executed, and that but you'll understand. Let's leave this for a while. Okay, so once you have written your code, feel free to press shift enter so that your code will be actually executed, and it will give you the output here. And that's nothing but you got 2 here because I have executed it 2 times. Okay, that's it. And that's how Jupyter cells work. Okay, super. Let me clean this. Let's press shift enter again. So now let us work with Python. Okay, I hope you are it's going good. And let's work with our COVID-19 analysis here. Practical session starts now, and it will end with another 10 to 15 minutes. Okay, I hope. Let me import my NumPy library first. Okay, so I'll say imports NumPy. Okay, so NumPy, and I'm gonna call it as NP. Okay, because NumPy is something verbose, right? I couldn't write everything. I couldn't write in my all my code. I couldn't write NumPy. I'll just call it as NP. Nothing but a short form. Okay. Say for an example, my name is Sujithkumar, but people won't prefer Sujithkumar. Okay, they'll be calling me as Sujith, or they will only prefer short names, right? So I'm gonna call NumPy as NP in my program. Okay, I'm gonna call NumPy as NP, and that is actually accepted by the community available for NumPy. Okay, the open source community. Okay, so let me import pandas also. So pandas, and pandas means not the pandas you're thinking. It's actually the panel data. Okay, if you're a beginner, this is actually new for you, right? Pandas stands for panel data. Okay, so pandas and PD. Okay, let's see, import pandas as PD, and usually most data scientists will import like that. I'm not a data scientist, sorry. And import NumPy. This will be actually used for, let me write a comment here, used for choosing your features. Okay, I'll be telling you what that is. This is used for reading and cleaning the data set. So what do you mean by cleaning? I'll be telling you that, because we got a lot of empty columns there, right? Okay, so import pandas as PD, and let me import my matplotlib library, mathematics plotting library, to plot the data from matplotlib. I don't want everything to be executed. I just don't want everything to be imported from matplotlib. So I'll be saying from matplotlib, I import a particular object called as pyplot. Okay, so from matplotlib library, just open your box, matplotlib. You got another box there called as pyplot, and import that alone. Okay, you don't want the other boxes. Okay, so as PLT, fine. So this is for visualizing data. Timing, I'm not writing the comment here. Fine, this is for visualizing data. Understand that? Fine. So let me import our original machine learning library that's called as scikit-learn, right? So you can import like this from sklearn. Sklearn stands for scikit-learn. Scikit-learn dot linear model. From scikit-learn dot linear model imports linear regression. Okay, so we are going to use a default class which is available in scikit-learn called as linear regression. If you instantiate that class, then it will create a machine learning model for you. Pretty simple. You can create a machine learning model just one time. Just import this, okay? But as a beginner, you can learn this, but I would highly suggest you to move on and write your own algorithm, okay? And if time permits, I will be I can be conducting one more webinar on that, how to write your own algorithm, right? Without importing this library. Fine. So and after that, I've imported this for my model. I just want to import one more stuff to perform train test split. Okay, I just want my data to be split as train and test, right? For that, I'll just from sklearn, I'll be importing a model selection. There is something called as model selection. Import train test split. Fine, train test split. And yeah, I think I'm done. I've imported 5 different libraries, and it will take some time for me to import actually. So I'm just imported NumPy, pandas, matplotlib, then linear regression, then model selection. Okay, think like that. Inside scikit-learn, we got a box called as model selection, and inside that we have train test split. You have to import like that because we don't want the whole scikit-learn to be imported. That will take more time and data, right? Okay. Once you have done, press shift and enter, and that's an asterisk, which means that this particular cell is actually getting executed, and you don't want to wait for this to execute. You can actually proceed, okay? And by the time you would have done this may be executed, right? So that's the important feature of this notebook, okay? You don't want a particular cell, you don't want to wait for a particular cell to be executed. Fine. So I think it's executed now. It's 3. It shows 3 here. Super. Because I've already done 2 times print hello world, right? So it's 3. Okay, fine. After that, Okay, to make this notebook more readable, I'll just cut this and I'll just paste it in the second cell. In first cell, I'm just having the heading. Okay, I'll just call it as importing all the libraries. Fine, importing all the. Not all means it depends upon our context. Okay, I'll make it as markdown. You go to this, you make it as markdown, and it will be taken as heading, not your Python code. Okay, press Shift Enter will be taken as your heading. Okay, superb, right? So after you have imported all the libraries, the next step would be reading the data set. Okay, so reading the data set. Hold on, guys. I know it's time, but I think this will extend for another 10 minutes. Okay, make it as markdown. Press Shift Enter. Okay, so next step would be reading the data set. Fine. So for that, let me be faster because I'm just going to increase my pace because the time is actually closer. Fine. So I'm going to use inside Pandas library, inside PD, I have a method called as read CSV. I hope you know about methods. Okay, that's not even a function. Okay, read CSV, and inside this, I just want to give my file name. That's it. Okay, my file name is public dn dataset. I hope you remember .csv. Okay, I hope you remember our dataset here, public cn dataset. So we just give that, and you don't want to mention the directory since this file is stored in a directory where your Jupyter notebook is set to. Okay, so you don't want to mention the path. Okay, so if you are storing the data set in some other directory in your computer, then you have to mention the path also. Fine. So let me assign it to a object or variable called as data. So I'm just importing the data set. I'm assigning it to a data. Fine. A variable called as data. I'm calling it as data. You can use any name. Okay. Okay. Super. I hope it is very simple. Press Shift and Enter, and that will execute it for you. And let me put data. You can also use some other methods to show, but time being I'm avoiding that. Fine. Let's say data and press Shift Enter. You got all the data set here. You got this is structure called as data frame. Okay, this is not the Excel sheet now. The format of this is known as data frame, Pandas data frame, because we have used Pandas library, right? So it's Pandas data frame. Okay, and the problem here is you got a lot of NaN columns. NaN stands for not a number. So you got a lot of none columns here. Okay, NaN or none columns, and my machine learning model won't accept that. So my first step would be removing all these none columns. Okay, removing all these none columns would be my first step. Okay, so let me remove all the none columns. For that, I can do that in just one line. Okay, that's pretty simple. Fine. So for that, I'll be writing the markdown as cleaning the data set. Okay. Make it as markdown. Go to here, make it as markdown. So it will be a heading. So for that, heading is optional. Okay, so for that, let me, I'm using data variable here. So put data. You can use a function called as drop na or drop na, which is available in Pandas library. Okay, so in Pandas library, we got a method here. So called drop na or drop na. I'm just calling the method using this object called as data. Okay, using this object, I'm calling the drop na method, and this will return me only the true values or unique values. In other words, this will remove all the none columns. Okay, and in original data we got 137 rows here, but in the filtered data we have only 75 rows, which means that 60 rows are none. Okay, so that's actually the origin of the data set, and you have to remove that. You have to clean the data. Okay, super. And after that, this will not be affecting the original data variable. So let me store it in a variable. Let me override it. Okay, let me override it in the data variable itself, so that our original data will be this now. Okay, this data set will be our original data set now. Okay, so if I visualize data now, and this would have removed all the none columns for us. Okay, this will have only the true values or just a number. Okay, fine. We got 75 rows and 19 columns. I just want to emphasize that we got 19 columns or 19 features. Okay, let me come back to Google Meet and ask you a question. I mean, question means, will it be okay when if I proceed the session, because it's almost 8 now. I hope you guys will be not be finding it difficult. I hope. Okay, fine. Okay. Can I proceed? Yeah, thank you so much. Thank you. Yeah, thank you. Okay. Please hold on for 10 minutes. I'll just complete it in a greater pace. Okay. So yeah, data. So you got the data set here. After that, yeah, you got your data. Now my point would be I have to determine which is my input and which is my output. I told you in the theory session itself, you have to choose your input and your output would be the thing which you want to predict. In this case, I just want to predict the positive cases. Okay, that's here. I think it's positive test. So it's called pos test here. I just want to predict that. Okay, so you want to predict pos test, and your input can be anything, right? So you can give everything as your input, but I'm not going to do that since my positive test will directly depend upon the total test, right? So because when total test increases, positive test will definitely increase in such a way, okay? Because we got data set like that. I'll be just visualizing and proving it that for you. Fine. So I have to choose only one input and one output since I'm doing linear regression with one variable. Fine. So I'll be choosing total test as my input and a positive test as my output, or the prediction, the target. Okay, positive test as my target and total test as my input. Okay, fine. So from this data set, if you want to fetch the total test, it's actually pretty simple. Okay, we just use the indexing method. So from data, from if you put the square braces, okay, can index like that, right? I hope you would have familiar with this in list. Okay, so you can index like this. You just mention the column name, and that will fetch the column for you. Okay, just mention the column name here. In this case, it is total test. That's my input here, right? Total test. I just want only total test and positive test. Okay, I don't want the rest data because those are not linear. Okay. Okay, press shift enter, and you got a series of total tests, and you got the serial number also because this is in a data structure called as panda series. Okay, we got something called as panda series, and this is actually in the type of that, and we don't want that to be in type of panda series because that will include the serial number also. Okay, so I'm just typecasting it as I'm just converting it as a numpy array. So there is a data structure called as array in numpy library. So I'm just converting this as a numpy array. Okay, so for that I'll just write np, or because I'm calling numpy as np, right? So np dot array, inside this I can pass this, right? Super. So if I press shift enter now we got only the values, not the serial numbers, in the form of an list, not list, in the form of an array. Okay, so I hope you know about if you don't know about numpy array, don't worry, you can check out my course in Udemy, which is actually dedicated for numpy alone. Okay, for numpy alone we got 2 hours of lectures there. Okay, fine, you can actually check it out that. Okay, so numpy dot array the data total test, and you can store it in a variable called as x, right? Because this is my input now, right? So I'll be just storing it as x. So let me press shift enter. Okay, I'll be storing it as x, and in y I'm going to do the same. Okay, I'm just taking the positive cases as my output. Fine. Okay, so if you press n, you got the total test cases, and if I press y, you got the positive cases. In that total, for means if you have a total case of this value, you got the positive cases of this value. Fine, super. After that, the point here is this is in the shape of a one-dimensional structure. Okay, this is actually one dimension. So my model will not accept that. I just want a multiple dimension. So I want it to be converted as a two-dimensional data. For that, I'm just using an inbuilt library called method called as reshape, that will reshape this data. Okay, so for the I just go to here, your x value, press dot. You can use it in the same line itself, since Python is actually doing object-oriented stuff, right? So you can do object-oriented stuff here. And if you don't know object-oriented programming, just go out and check out the course. Okay, I have a course in Udemy for that also. So put dot here and reshape. Okay, this takes 2 arguments. One will be your number of rows, and other one will be your in each row how many number of elements you want. That's the second argument. Okay, and that's how we can convert this as a two-dimensional data. Fine. So I'll be putting -1 here. So why -1? Because when I say -1, it will fetch up to the last row. Okay, so I hope you know the basics of Python. So when I say -1 in Python, it actually refers to the last element, right? So when I say the number of rows as -1, it will fetch up to the last row. Okay, and in each row, I just want only one element. I mean, in each row, I just want only one data value. Okay, that's how I can convert this as a two-dimensional data. Fine. So in each row, I just want only one data value, and I'll be doing that for this also, because my model will accept only two-dimensional data. That's why. Enter. And X, I'll just put here, and you got the data like this. In each row, you got only one value. That's how we can convert your input and output as a two-dimensional data. Super, right? So this one-dimensional data, just shift enter alone, you can convert like this. Fine. Moving on. So now we have determined our input and output. I'll be just doing that here. Determined features. Okay. For time being, I'm not writing the markdown. Sorry, I'm almost close. Fine. So moving on, let's actually plot the data. Okay. Plotting the data. Otherwise, it's called the visualizing the data. So it's actually pretty simple. For that, I'll make it as markdown. Okay. For that, I'm going to use scatterplot from which is available in matplotlib library. I've already imported that in the first cell. So PLT, because I've imported pyplot as PLT. Okay, you can see that pyplot as PLT. So PLT dot. I'm just using a scatterplot here. So I'm just scatter. That's a method available called as scatter. So use that. You have to pass your input and output. My input is X here because I've stored my total test cases in a variable called as X, and positive cases in a variable called as Y. So I'm just passing X, Y here, and after that, just that's it. You got only two values. Press Shift Enter. It will actually plot the data for you, and that's how your data looks like. It's almost linear, right? Let me label this also. PLT.X label total test. Okay, you can give any name. Label is nothing but labeling your X and Y axis. Okay, positive total test and positive cases reported. Positive cases reported in that number of cases. In that number of tests. Okay, and PLT.title, I just give a title called as COVID-19 situation. Okay, COVID-19 in PN. Okay, so sorry, wait a minute. Time stops. Okay, so put Shift Enter. Yeah, we got total tests here and positive cases reported here and title here. Fine. So you got the data to be almost linear, right? So it's very easy for my model to fit a line here. And if I fit a line here, that will almost fit my data, and my model would be highly accurate. That's why I have chosen linear regression for this particular data set. In practical cases, it is also practical case, but it would not fit a curve like this. It's actually very smooth and explains the situation of curve, right? So almost linear. So if I fit a line here, my cost would be very, very minimal. So that I'm getting more accuracy. Fine. So yeah, we are into the crazy part now, creating the model. Fine. Okay. I thought I'd find it nice. I put that. So creating the model. So create a model. For that, let's call the class called as linear regression. And we have already imported that in the first Excel itself. Linear regression class, and you have to create an object of the class. Okay, you can create a particular class. If you learn more about programming stuff, you can check out my code as programming in Python. Just go to Udemy and Sujithkumar and get my courses there. Okay, fine. So model equals to linear regression. That's how you can instantiate a class. After that, press Shift Enter, and now your model is actually created. Okay, so now we have created a machine learning model, a linear regression model called as it's actually called as model. You can give any name here. Okay, so in my model now I'm going to train the model. Okay, I'm going to train the model. Training model. Okay, so for training the model, I just want it to be, I hope, I want my X and Y to be split as test and train data. I forgot that because I'm in a rush. I'm in a hurry up mode, so I forgot that. So let me press another cell here. Okay, let me create new cells here, and let me split my X and Y as train and test data. Okay, split X and Y as train and test data. Okay, I just want to rush up, that's why I missed that, sorry. Okay, train and test data. Fine. Okay. Because for training, I told you that for training, I'm going to use only, if I have 74 columns here, I got 74 columns, 75 rows here, 75 rows here. I'm going to use only 50 for training and less 25 will be taken for testing. Okay. So I just want to split 50 rows from that. For that, it's pretty simple, guys. You have to use train test split function available and method available, or class, I think it's class. And inside this, you have to pass your X and Y. And after that, you have to pass one more parameter called as test size. Okay, and that should be set as 0.2. It's nothing but it determines your size of your test data. If I put 0.2, 20% will be taken for test data. Okay, if I put 0.3, 30% will be taken for test data, and the remaining will be taken for train data. Okay, you can mention that's an optional parameter. Okay, put comma. You have to mention one more parameter called as random state and make it as 0, and that's actually splitting parameters. How your data wants to be splitted. Either you want to split the first row for training, second row for testing. You can split like that randomly, or you can split in an order, right? So if I make random state to be 0, it will split in a particular order. Okay, that's why I'm making random state to be 0. Fine. And I have to store this split in some data values, right? In some variables, right? So I'm just splitting X and Y. X is my input and Y is my output. X is my total test cases and Y is my positive cases. I'm just splitting it as train and test. So I'll be getting 4 variables, right? For X, I'll be getting training and testing, and for Y, I'll be getting training and test data. So I'll be having 4 variables here. So I'll call as X train, Y train, X test. Sorry, X train. I think it's X train, X test, Y train, comma, Y test. Put equal to. That's it. Now your X will be split, your X data will be, that's your input will be splitted as train data, test data, and otherwise your output will be split as train data and test data. That's how you can split your train. You've got 4 variables here since you're splitting 2. If you split 2, you'll get 4, okay? And you can actually check the shape of that. I'll be using np.shape. That's an inbuilt function available again to check the shape. And it will be, wait a minute, I have to execute this, sorry. Okay, so I got an error there. Wait a minute. And I got 60 rows for training. Rest will be taken for testing, I hope. So I'm just printing np.shape also. I got 15, I initially had 75 rows. So I now have 60 examples for training and 15 for testing. For Y also it will be same, because Y is nothing but your output and your input actually maps your output, right? So for now, training will be, we are having the input training data and your Y train, that is your output training data. So for training, we have X train and Y train. For testing, we are having X test and Y test. I'm just telling this because this may confuse you. Fine. So now let's go back to our model. So I've actually created the model. Okay, so in this model, let's train our model now. Okay, so training our model. Fine. So just put model dot, because our model variable is here. So model dot, this is your linear regression model. Okay, so model dot, use a function called as fit, and that will do all the algorithm steps for you. I told you a flow of flow, right? That's fitting a line, minimizing the cost function, and all those steps can be done with just this one function called as fit. Okay, and you just pass the train data here because we are training the model. Okay, just pass the train data here. Super, right? So now my model will learn from this train data will actually fit a line to this train data. Okay, now I'm just press shift enter, and that's it. My model is now ready to predict. Okay, ready to predict something good. Okay, so I've created the model and I've just passed my train data to the model. Okay, to fit the model. Okay, super. And yeah, that's it. Okay, train the model. So my model is now ready to predict. Before that, I'll check the accuracy of my model. Okay, how accurately it will be able to predict. I'll check the accuracy of the model. For that, checking the testing, evaluating the model. It is called as evaluating. Okay, it's like evaluating our exam sheets. Okay, evaluating our model, making it smarter. Okay, fine. Evaluating our model, and for that I'll just use a method available called as score, and that's also a default method available in scikit-learn library. So called as score, and now you have to pass the test data because you have passed the train data to train the model. Now you have to pass the test data to predict your accuracy, right? So X test and Y test. Press shift enter, and I just multiply this with 100. That's a normalization stuff. Okay, and you got 97% accurate. And I hope I have justified this. My model is now 97% accurate because my curve is almost linear. My data is almost linear. So I already told you that my line would exactly fit to this data. That's why I've chosen linear regression for this data set. Okay, and you should be in a position in the future to choose a particular approach for a data set. Okay, for this data set, linear regression is absolutely fine. Okay, so my line would actually fit to this data sets. Fine. Super. So this is 97% accurate. Okay, so how this score method actually works, for each value of X test, say for an example, let me print X test here. Okay, so X test data, that's you got 70, I think it's 7,41,737 test cases. For that, it will predict the value of positive cases. Okay, for each value of test cases, and it will predict the value of positive cases, and that will be compared with your original value because you are passing the original value also. That's why. Okay, that will be compared with your original value, and those values are 97% accurate. Okay, I just want to emphasize that. Okay, for each value of test cases, it will predict a value by default, and that value will be compared with the original test value, and that's why it is 97. That's how it is 94 method works. Okay, so that's how we can evaluate the model. Now let's actually predict the values. Okay, let's see the predictions. Okay, so predict the values, and that's the last part of this webinar, right? Fine, let's predict the values. So you have evaluated the model that's 97% accurate. So let's predict the values. For that, let me say model dot. I use a method called as predict. So predict, I'll be passing only X test here, not the Y test, because I just want it to predict. Okay, so you pass only the input, not the output. For score, we just want the accuracy, so we passed both, but here we are passing only X test. Okay, press shift enter, and you got the predicted values here. Let me just compare it with the original value. Or I'll just say not model, Y test, that's my original value, right? Put shift enter. You have the predicted values here and the original values. Predicted value here, it is 48,523. Original value is 45,000, and these values are almost 97% matching. Okay, so you got 30,661 here. You got I think 36,000. I think here something somewhat it matches. Okay, so you got take the last data to 29,570. You got 26,000 here. 97%. These data are actually matching. Okay, that's why you got an accuracy of 97%, and that's how a linear regression works. Okay, first of all, I just quickly recap in 1 minute. First of all, import your libraries, your needs, and in future you'll be able to understand this if you start learning this, and read the data set. After that, clean the data set using drop now. Okay, clean, remove all the null columns, get only the true values. Make it as a choose your input and output. In this case, I have chosen total test as my input and positive test as my output. I mean this column, This I think moving on. Yeah, here. This column as my input and this column as my output, because they are directly proportional. That's why. And you can see we got 97% accurate. And you can include other features also. Okay, so X as my input and Y as my output. Typecast it as numpy array. Put your reshape method to convert it as a two-dimensional structure. Moving on, split it as a plot your data. Okay, just to analyze. Okay, it's not compulsory, just for you to understand the structure of data. And this step is actually crucial. Split your data as train and test split. Okay, so we got 60 rows for training and 15 rows for testing. And create your model. Fit your model. Train your model with your training data. Evaluate your model using score. Pass your test data here. Multiply with that. I'm sorry. This. Multiply that with 100 to get the normalized value in percentage. And now you predict the values using predict method. You pass only the input and you just compare it with your actual output. You will be getting the output. You just compare it with your actual output, and that's how linear regression works. And thank you so much for attending. Thank you so much for keeping patience. Okay, I hope I have. Thank you. Thank you so much.